Hey y'all, today in this video we're going to be talking about inscribed circles, finding angles, and finding arc lengths. So essentially what I'm saying in this video is that we're going to be talking about finding the angles that are constructed past the center, and we're going to be looking at the actual distance that it creates. So if this is angle ABC, so if this is angle ABC, which is being constructed right here using these two rays or these two lines, whatever you would like to call them. Those angles ABC will let us know that we can find the distance from A to C. So we can find the distance from A to C, but knowing that we have to take half of this distance or half of that. So if we know the measure of A to C, then if we take half of it, we know that we can find the inner angle of that specific intersection, or where the two rays meet, is what I would be saying. So this is just a way of finding out angles or finding out distances from 2 points. Now another interesting thing to note on this is that so if you had seen from the previous videos of arcs or areas of sectors and arc length, we've always talked about the radius being from the middle. And so radius is from the middle. But if you notice that these lines or these rays or these lines, they're not from the center. So what we have to assume now is that those same rules do not apply to us, so we can't assume that the measure of the angle ABC is the exact same thing as AC. So that's why we get to say this, knowing this formula now. So let's go ahead and take a look at some examples, and we'll kind of look at how they construct. So here first, I'm going to go ahead and focus on problem number 5 here. So if I look at problem number 5 here, we have a giant circle here. Now the idea right now is that we're trying to find, and it's odd because it does something like this, LJKM. We know that this is 120, which may not even be useful. This is 43 degrees, and this is 46. So this could be confusing because now we're looking at, well, what would this angle be? Well, we have to be kind of understanding of what the information is. So first of all, the question is asking us that it wants us to find the measure of J to L. So if we look from the measure of J to L, we're actually looking at this whole outer piece here. We're wanting to find this. So if we go ahead and look at that, we get to say that, well, this turns out to be this inner piece here. So what we can go ahead and do from there is we can just go ahead and use the formula that we already had. So we'll get to say that that's 43, and I reverse it. So we'll use the formula that we just knew a minute ago, or we took a look at. So if we look at the measure or the angle of LMJ and say that is equal to half of J to L, because remember, that's what we said. If it was the blue angle, if the blue distance, then it'd be the inside matching one. So if we go ahead and plug in the information that we know, then we can work backwards to figure out what we want. So we know the measure of the angle LMJ, which is 43 degrees. Then we get to say it's 1/2 of JL. But wait, if I go ahead and multiply by 2 to help solve for JL, we can go ahead and see. So then that would be 6. So 86 degrees would turn out to be the measure of J to L. Sorry for crossing that out. But yeah, so we go ahead and see that the measure of this is 86. So the whole distance of the measure of angle J to L, the whole arc right there, that is 86. The units is what we normally go by. In this case, it wouldn't be degrees. It would just be, since it's more of a distance, and really it is an angle. So we're going to say it's 86. I'm going to go ahead and erase that. So that is the go ahead for that piece. We still got time for one more practice problem here. Now we'll be looking for M to J. Well, now the 120 will actually become useful. So we'll look at question number 6. So using the same image, we now know that this measurement here, so it does something like this. We know that from here to here, or let me put this in blue. So we know that this measurement, because this is L, this is J, this is M, this whole thing is 86. Now, if this is 86, this is 120, we can go ahead and add up the measurements together, and we can just go ahead and call it a day on that. So since they want us to know what's the measure of M to J, we can go ahead and say what's 120 plus 86. So that's 6, 10, 2. So we'll be looking at 206. 206. So that would be the measure of M to J. So in some upcoming videos, we'll talk about more of inscribed circles. We'll go ahead and look at different ways, different polygons, different shapes. So this is just an understanding of inscribed circles. Thanks a lot.